So generally matrix question when framed in any competitive exam becomes tough to solve. Generally it is not all the tough, but its calculations, its product makes it complicated. So this question is also not tough, but it is calculative. First of all, let's look to our question with that is beta is a real number. It means that beta is a real number. Consider this is matrix. If this is a type of matrix expression is given is a singular matrix, then the value of 9 beta is. I expect that you all know that what is the meaning of singular matrix. Singular matrix means that if A is singular matrix, singular matrix matrix then determinant of that matrix will always be 0. Okay, so since this whole expression which is given here, this expression is obviously it will result as a matrix. Since we are doing matrix operation here, so this will result as a matrix, and that matrix has determinant 0. So this matrix will also give me as determinant 0. So if I write the statement determinant of a to the power 7 beta minus 1 a to the power 6 minus beta a to the power 5 is equal to 0. Let me take as a to the power 5 as common, since it is common. A to the power 5 into uh, a to the power 5 into a square minus beta minus 1 a to the power simply it will be a minus beta is equal to 0. So we can separate if let me introduce let me write one thing here. Is this was the first concept, this will be second concept. If there are two matrices such that it is A and B, so we can write it as determinant of A into determinant of B. It means that product after multiplying these two matrices and then taking determinant will give me same result as individually if we take both determinant of matrices and then multiply them. Okay, and third concept let me introduce, it will used further, which will be if there is determinant of a to the power 5, then it will same as determinant of a whole to the power 5. Okay, these all three properties are going to used here. These all three properties are going to since this is used and this will be used and this will be used now. So let me use this property determinant, and a to the power 5 I have discussed that this determinant of a to the power 5 will can be written as determinant of A whole to the power 5 into determinant of A square minus beta minus 1 and 2A minus beta will be equal to 0. So there may be two two means there will be these type of possibilities that this term may be equal to 0, this term may not be equal to 0, this term may equal to 0, this term may not be equal to 0, or these both terms can be 0. These all three possibilities with these both products will terms may have possible. So let me check what is determinant A is going to be. Since we can calculate determinant A easily, so what will be determinant A? Again, I'm not going to explain how to find determinant or how to expand this determinant or solve. You must know how to solve a determinant. Okay, so directly I'm using the expansion. First of all, I will expand this determinant using this row. This row I will use for expansion. Okay, so first of all, beta into minus 2 plus 2. Okay, minus 0, anything will be coming will give me 0, so no need of writing that things. And then plus 1, there will be 2 minus 3. So here we can say that this term is going to 0. So the determinant which is coming as minus 1, determinant is not of beta. Okay, so we got that determinant is not equal to 0. Okay, so with not equal to 0, these two terms we have combination this. So determinant this one, so this one must have 0 value. Okay, so now we will be going with this term. So as we know that here is mentioned a square, so first of all let us calculate what is the value of a square. Since a is matrix of beta 0 1 2 1 minus 2 3 1 minus 2 2 1 minus 2 3 1 minus 2. If I talk about a square, then we have to multiply the same matrix again. Minus 2. Okay, so so you all know the multiplication of matrices, how it is done. So I am going to write directly what is going to come here after multiplication. So beta square plus 3, first row first column, and again beta will be beta into 0, 0 into 1, 1, then beta into 1 minus 2, beta minus 2, then 2 beta plus 2 minus 6, 2 beta plus 2 minus 6 will be minus 4, then 1 minus 2, that is will be minus 1, then 2 into 1 minus 2 will be 0, and then minus 2 into minus 2 will be 4. So after that 3 beta plus 2 minus 6, again there will be 3 beta minus 4, 3 beta minus 4, after that there will be minus 1, and 3 minus 2 plus 4, 3 minus 2 plus 4 will be 5. So a square is this. So let me write the equation. So equation was determinant of a square minus of beta minus 1, I think, beta minus 1 into a minus beta, okay, minus of beta minus 1 into a minus beta will be equal to 0. So determinant of, let me write here that matrices will be beta square plus 3, 2 beta minus 4, 3 beta minus 4, 1 minus 1 minus 1, beta minus 2, 4, 5, minus of, after multiplying beta minus 1 into a, so directly multiplying here with beta minus 1 to a matrix, there will be beta square minus beta, then there will be 0, and then there will be beta minus 1, and this will be 2 beta minus 2, this will be beta minus 1, this will be minus of 2 beta minus 1, again this will be 3 beta minus 3, this will be beta minus 1, and this will be again minus 2 beta minus 1. Got it? And next term was beta, so let me write this term here, beta. Since we know matrix, a matrix can be only operated through matrix, so addition, multiplication, sorry, if we add if we want to add two matrices, they must have same rows into columns, okay, so there must be multiplication in the multiplication of the identity matrix, okay. So here I will be writing my identity matrix 0 1 0 0 0 1, okay. So finally that, see, I am calculating here on here itself. See, beta square will be cancelled from this, since here is a multiplication of minus, and minus minus will be plus beta, and here is also minus beta. Okay, so this will also be cancelled with this. Okay, so I will be writing here beta square is cancelled, beta is cancelled. Okay, so there will be only 3. So if we calculate of this second column, first row will be 1 minus 0 and minus beta. So 1 minus 0 minus beta will be 1 minus beta, and beta minus 2 minus beta plus 1, it will give minus 1 and minus beta. So minus 1 minus beta. Okay, sorry there, I have made a calculation mistake. As you know that 1 uh, this 1 minus 0, 1 minus 0 minus 0, there will be only 1. Again similarly here will also there will be no beta, since there is 0, so no beta will be there. So after that 2 beta minus 4 minus 2 beta plus 2. So we can say that we can see 2 beta is cancelled, and minus 2 remains, and there will be minus 2. So minus 1 minus beta plus 1, 1 1 cancelled, and again minus beta, so there will be, so minus 2 beta. So 4 minus 2 beta, although it is plus 2 beta and minus 2. So let me write here 4 plus 2 beta minus 2. This 4 minus 2 will be 2. So 4, there will be 2. So 3 beta minus 4 minus 3 beta, 3 beta cancelled, minus 1 is there, and minus 1 minus 0, so minus 1. So minus 1 minus beta plus 1, 1 1 again cancelled, and there will be beta, and then also beta minus 0, 0 will be from third matrix, this is beta. Minus 1 minus beta, then it will be minus beta. Yes, it will be minus beta. And minus, sorry, 5 plus 2 beta, 5 plus 2 beta minus 2 minus beta. So this 2 beta and beta will be compensated. So this will 2 will not be there, and 5 minus 2 will also be as 3. So 3 plus beta will be there. Fine. This determinant I want 0. So although it became like this, 3 1 minus 1 minus 2 beta, 2 plus 2 beta minus 1 minus beta, 3 plus beta is equal to 0. If we apply here a rook operation, that R3 goes to R3 minus half times R2. So what will determinant be is 3 1 minus 1 minus 2 minus 2 beta, 2 plus beta, 2 plus 2 beta, and R3 is minus 1, and minus of half R2 will give us plus 2 plus 1, sorry, this will 0, and this will also be 0. Minus beta, minus minus plus of beta, this will be 0, and 3 plus beta minus of minus 1 minus beta, again beta will be 0. So 3 minus 1 what? 2. Okay, so this is RHS actually. Okay, expand this determinant with respect to this row. So we can say that with respect to this term, with respect to this term, the expansion will be 0. We only will be expanding through this term, this, and this term. Okay, like this. 6 beta plus 2, minus 6 beta. So there will be, if I talk about, sorry, so there will be minus 6 beta plus 2. So if I talk about LHS part, there will be minus 6 beta plus 2 is equal to 0. So beta will be 1 upon 3. So hence we calculated our beta. But in the question there is asked 9 beta. So what will be 9 beta? Since beta is 1 upon 3. So 9 beta will be 3. Fine. Since we can see that the matrix calculation make this question lengthy, but the question was not as tough. So thank you for all the friends for being here. If you like the solution, like this video, and if you want any or such more videos uh, explained in this similar manner, so subscribe to my channel Mathera, and thank you and have a nice time ahead.